synthetic's easier, isn't it?
Yeah. It's really easy.
By a lot.
Okay, so questions, concerns, and issues we had in the synthetic division.
Just the last question.
Yeah, I was a little confused on 24. I'm not sure if I did it right. I got a whole bunch of crap.
Is it just because of the fraction?
Well, not necessarily that. I was having.
I've converted it all to decimal because I can understand it better that way.
And then went back, okay.
Just the end where you have your remainder, and it's like the 49, I got 49 over 8 over x minus 3 halves.
Mm-hmm.
And I'm trying to make it, I don't have a
Oh,
fraction.
gotcha. Okay.
Can I say what I did?
Yeah.
So I got the same thing, and then I just multiplied top and bottom by 8, and your 3/2 becomes 12 when you multiply by 8.
Mm-hmm.
Multiply by 8? Yeah, well,
Yep.
top and
Yeah,
bottom.
that's what I did too.
Yeah, so then you end up
With 49.
49 over 8x minus 12? Yep. So then you end up with 3x squared plus 1/2 x plus 3/4 plus 49 over 8x minus 12. Okay, so you feel pretty confident in multiples?
I got
Let me take 3 halves times 8
over
over
8
8.
x minus 12.
Okay.
This is like my favorite part about algebra, like dividing it and stuff.
It's great.
Yeah.
X minus 12, 49 over x minus 12.
49 over
8x
8x
minus 12.
minus 12. Yep. 8x minus 12. Yep.
Okay, I got it.
Alright, any questions on any of the others? Katie?
What are you supposed to get for 22? Because I got a
22.
really big number.
X squared plus 9x plus 81.
That's what I got.
Okay, I got a remainder on that.
Okay, so that's not what you got?
No, I got the x squared plus 9x plus 81, but then I got a remainder above it.
Oh, you got
Probably a
remainder.
sign problem or something.
Yeah. Maybe a negative somewhere in there. Because you put in your placeholders, right? A 0x squared and a 0x.
Yep.
Minus 729.
Yep.
And then you used a positive 9?
Yeah. I probably just multiplied wrong.
Could be. Well, try to find the error. If you can't find it, let us know, and we'll help you. There. Okay, any others?
I still can't get 24.
Okay, let's
I
go
can
ahead.
get
Let's do 24. So we have, so for 24. Okay, so we'll have 3 halves in the box, right? I'm gonna give myself enough room, so I'm gonna have some fractions in there. So we have 3x to the third, negative 4x squared, 0x, and 5, correct?
Oh, it's a negative 4. That's where I was.
There it is, okay. Glad I could help.
How do you finish that?
Okay, let's go ahead, let's finish it for Maddie and Megan's sake, right? Okay. So we bring down the 3, don't worry, we'll do some more synthetic in class.
Be 9
So
halves
so we just bring down the first number,
times it by
and then
3
we
halves.
multiply that 3 by the 3 halves.
You get 9 halves.
Oh, and then you put that
And that goes,
under the negative 4.
yep,
And then
you add.
Then you get 1 half.
Negative 4 plus 9 halves is
1 half.
positive 1 half.
Then you multiply that
You
and put it
multiply,
under 0.
so that would be 3/4, right?
So then you get 3/4.
You get 3/4.
Then we get 3/4. And then we multiply that by 3 halves, and that's what? 9.
9/8, yeah.
And you add that to 5, and that ends up giving me
49/8.
49/8. So this last bit is the remainder. That 49/8 is the remainder. The original divisor was 4x to the third. So that means my quotient is going to be x squared. So I'll have a 3x squared plus 1/2 x plus 3/4, and then plus 49 over 8 all over my divisor, which is x minus 3 halves.
Synthetic division can only use an x
An x plus or minus something. Yep, if there's anything else multiplied by the x, you can't do it. If it's an x squared, you can't do it.
So then that last number is your remainder, and then you write this
Over your divisor. Yep, and then on this one, we had it having a fraction within a fraction, so we multiplied top and bottom by 8. To get rid of that fraction within a fraction. To end up with 49 over 8x minus 12. Alright, so now the whole purpose for this. Okay, now we're actually getting into the whys. Okay, the whys of doing this is to actually help us factor down a polynomial. To get it factored down, because once we have it factored down, we can solve it, right? Really, our only way of solving, if I need to solve a polynomial, we can solve it if it's quadratic, aka x squared is the biggest thing we've got, right? X squared. If it's quadratic by completing the square or quadratic formula, do you guys remember that?
Yeah.
C equals
B
negative
plus
b plus or minus the square root of b squared minus 4ac
all
all over 2a. So we can solve a polynomial if it's quadratic. If it's not quadratic, but completely factorable, we can solve it. Right, if we can factor it down. Okay, but then we have a third group over here that is not easily or at all factorable. And this is where we're like, okay, what do we do with those guys? How do we solve them? Okay. So this is where this whole dividing things comes from. Because if I can find one of its factors, I can divide to find the others. Does that make sense? It's very similar to if I have a big number, 128, and I want to know, hey, what goes into 128? Well, we would start with an obvious that we know, well, it's divisible by 2, right? So we would divide it by 2 and see what we get, right? Or that'd be 64. And be like, okay, well, we can divide it by 2 again. And if you remember, we would do these actually with trees. And then, okay, 64, we can divide that into 2 and, what, 32. And then, so we can get all the factors of it. And so that's kind of what we're going to be doing with these polynomials. Because we know if we divide by something and we get a remainder of 0, then we know it's an actual factor, right? All right, so to get to there, we're going to look at one thing called the remainder theorem. Don't worry, we're not going to prove it.
Flashbacks to geometry.
Somebody's like, are there theorems outside of geometry? I'm like, the whole entire math system is based on theorems. So yes. But do we spend a lot of time proving them outside of geometry? No. Okay, the remainder theorem. I like to think of the remainder theorem as a quick little shortcut. Shortcut for putting numbers, for plugging into a function. Shortcut for plugging into a function. Into. Okay, back in the day before graphing calculators, the remainder theorem was hugely used. Okay, right now it's not used as much because it's quick and easy for us to plug stuff into a function without it. What I mean by plugging into a function is if I had a function, 3x cubed plus 8x squared plus 5x minus 7. And I longhand wanted to figure out what f of negative 2 was. I'll put negative 2 to that. Okay, so I need to take, so to do that, I would need to take, take negative 2 to the third power, multiply by 3. Take negative 2 to the second power, multiply by 8. Take negative 2 times 5, and then add up all those things, right? Negative 2 isn't too bad. If this was like a negative 12, that would be a whole different story, right? I have to take negative 12 to the third. That's a whole lot of multiplication if I'm doing it without a calculator. Okay, what the remainder theorem tells me is there's this neat little trick with these polynomials. If I actually synthetically divide this, if I divide this by the 2, the remainder I get out is what I would get out if I plug the negative 2 in. Okay, so basically the factor, if I'm synthetically dividing by negative 2, do you agree the factor is an x plus 2?
Yes.
Right, that's the factor. Okay, if this is a 0. Okay, so I can actually synthetically divide this by the negative 2. What I get out right here for my remainder, let's say my remainder is k, is what I would get out here if I put that negative 2 in.
So what if there was like an X in your remainder though?
There won't be,
Like never? Okay.
not when synthetically dividing. Long as it's
So if that's like a
Oh.
3, then it'd be x minus.
minus 3 would be the factor.
But like on 24, it's 49 over 8x minus 12. So,
No, she's talking about
But
just
the
the 49.
remainder, it would just be the
oh,
49.
it's just, okay, I see.
Just that 40, well, in this case 40, it would be the 49 over 8 to start with, right? So we don't actually care about any of the stuff in between here. We're just working it out to get to that remainder. Okay? So I could actually plug in -2, so if and we can check this one. Let's plug in a 3. We'd have 8, 5, -7, right? Let's do the work on this. So we take a 3, that gives me what, -6? 2, -4, 1, -2, -9. So I end up getting out f of -2 is -9.
That's cool.
And so if I actually plug the -2 in there,
You get
you get -9. Because of that, you get -9. It was a shortcut way, and look, our numbers are all really small, right? We didn't have a number above 10. Now, if I would have took -2 to the third, well, that's -8, I can multiply that by 3, already I'm bigger than 10, right? Keep your numbers small.
24.
So this is using the remainder theorem to find what f of something is. Okay. And you can always check it, okay?
So if you plug a 2 in there, the answer would be -9.
Exactly did it. You got -9. Yeah. So it's a shortcut. Okay. It was used a lot back before graphic calculators. You could very easily type that whole expression in and hit enter. Okay, when you had to do it all by longhand. It's not used as much anymore, but it is handy. It's a nice little trick. Especially if you're taking something timed and you remember it, you can just very quickly plug it in. Okay, so that's the remainder theorem. What happens if I work a synthetic division out, for example? If I work a synthetic division out, and I get a remainder here of 0.
Then your factor 0,
Okay.
or whatever you get
Yes,
in there.
then
is
my
0.
number here, whatever my number was here, I don't know, it's gonna be a, then I know this is a 0 of the function, right?
Oh.
Because when I put it in, what I get out?
A 0.
A 0. So I know that's a 0 of a function. So then that means that x minus a is a factor of that function, correct? And not only is x minus a a factor, this guy here, what's left, is the other factor, right? So we can actually use that to factor down completely a polynomial. So we're doing that in example 6. In example 6, they give us a couple of the factors and we want to show that they're factors. So they ask me to show that x minus 2 is a factor and x plus 3. We want to show that they are factors of this function, f of x equals x to the 4th plus 7x to the 3rd minus 4x squared minus 27x minus 18. Okay, so we want to show, this is on page 121 in our book, it's example 6. So we want to show that those two are factors. Well, if they're factors, then x equals 2 is a 0, correct? And x equals -3 is also a 0, correct? So for me to prove they're zeros, I could plug it in to the whole entire function and make sure I got a 0 out, or I could use the remainder theorem, synthetically divide to get that 0. So I'm going to do that, so I'm going to use the remainder theorem. So that means I need to plug a 2 in, right, like that, 2? 1, 7. So 1, 7, -4, -27, -18. Alright, bring down the 1, multiply it by the 2, 9, 18, No,
Yeah, 28.
1,
You get 2.
2. So is it a factor?
Nope.
What happened? It should be.
It should be.
Oh, it was a problem child wrong. 2x to the 4th.
Boom.
Now, let's go back and
Scratch it. -4. Okay. 2. 4. 11.
Oh, yeah, 22.
22. 18.
36.
36. 9. 18.
0.
Woohoo! Remainder of 0. So we have just proved that x minus 2 is a factor. So that means x equals 2 is a 0. We found a 0 of that function.
And do 3 now.
So now we have to do 3, but instead of going back to the original, can I just work with the now simplified version of this? The now divided? Basically what I'm doing is instead of going back, it's like this factor tree here. Instead of going back to the 128 and dividing it by 2 again, what do? We work with just the 64 and divided it by 2. So we're going to do that same thing here.
So with the answer you got, you're going to make it an equation that divides
So
it?
now, I'm not even going to make it an equation. I'm going to go -3,
Yeah.
Oh.
step it
Oh,
down.
I remember this. Wait.
Yeah, we did this before, right?
Wait, how can you do that? Cause I'm confused.
Okay, so basically what we've just determined is that this guy right here can be written as x minus 2 times 2x squared, to the 3rd, plus 11x squared plus 18x plus 9. Right, this guy?
Yep.
Okay, so now what we're doing is now we're seeing, we're dividing into this guy. Because if I divide into that guy and get a 0, then I know I'll have it broken down even farther.
Why wouldn't you go back into the original?
You can go back to the original.
But it'll work if you don't.
It'll work if you don't. And actually, we like it better when you don't. Because right now, this is the next to the 3rd still, correct? Do we have a cubic equation like our quadratic one? Do we have an easy way of solving an x to the 3rd? No. So if I divide the simpler one by this next one's now going to be an x to the 2nd.
And then you can take it.
Then we can use a quadratic formula and all kinds of other stuff to solve it. We can complete the square or do whatever we want with it. But I couldn't do it if I just kept dividing into that. Does that make sense? Okay, so we're just going to divide now again by that -3. So we break down the 2, which gives me -6,
5.
5,
-15.
3.
0.
So now I have this guy pretty factored down. I know I have a factor of x minus 2. I know I have a factor of x plus 3. And what's my remaining factor?
2x squared plus 5x plus 3.
So now I know, I have solutions to this. If I was setting this equal to 0, I've got a 2, a -3, and then now can I do some stuff with that?
Yeah.
I'm going to try to factor it.
So what happens if you don't get zeros?
Then it's not a factor.
So then you stop.
You'd have to try something else. Yeah.
Either that or make sure you wrote the problem.
From down, yes. If the problem is asking you to show that it's a factor, and you don't get a remainder of 0, you probably do it somewhere.
So pretty much every one is gonna have a negative.
If they're asking you to show that it's a factor, yes. If they're asking, is this a factor? It might not. Just depends on what they're asking. Alright, so then we can actually use this to help us solve equations. Okay? With one little extra thing, and this is the rational 0 test. I know you guys are all gonna go and see it, because I know you didn't like it back when you do. The rational 0 test. If a polynomial has a rational 0. Sure. a rational zero?
Wait, what's a rational zero?
Good question, I was just gonna explain that. What the heck's a rational zero?
Only occurs once.
Okay, not necessarily.
It can be rationalized.
Rational, whenever you think of rational, I want you to think of fraction.
When you have a zero, that's a fraction.
You have a zero that's a fraction. But again, be careful. Is 2 a fraction?
No.
Technically, yes, it's 2 over 1.
Oh, no.
Okay, what about 1/3? Yes, what about -6?
Basically,
Sure,
the.
-6 over 1. Which ones aren't rational?
Zero.
0 is actually rational.
It is.
0 over 1.
Wait, so what's rational?
1 over 0 is not.
1 over 0 is not, no.
So that's not.
That's undefined, that's not a number at all. But an example of not rational, square root 2. Can I write that as a simple fraction? No, what about pi?
Could you do square root of 2 over 1?
No, because the fraction has to be both integers.
Oh, okay.
Has to be an integer divided by an integer.
What's an integer?
Yeah.
0, 1, 2, 3, 4, and they're negatives.
Oh, okay. Number,
Negative 1, 2,
a
3,
fraction
4.
that has a negative in the denominator, right?
Yeah, you can have a negative in the
Yeah, I
numbers.
didn't know
That's
that was either, Raina.
Do you know when you were first introduced to integers?
Like second
Long time
grade.
ago.
Yeah, like
Never.
5th grade is when they first actually really start hitting with integers. And guess how many years you've actually done integers?
Since then,
Yeah.
every day,
Like,
yeah.
Yeah, every year since then.
Singapore, man.
Okay.
Oh, do you remember Singapore?
Every day since then. Okay, so a rational zero is like a fraction, meaning non-ending decimals are not rational. Okay, unless there's a repeating pattern, right? Non-ending, non-repeating. So meaning if the decimal has no end and it doesn't repeat, it's not rational. Because you can't write it as a fraction. Can you write it as a fraction, a division of 2 whole numbers? No. Square root of 2. Can I write it as the division of 2 whole numbers? No. What about pi? Can I write that as a division of 2 whole numbers? No. 1 plus or minus root 5. Not rational. Okay. And we know we have zeros that look like that sometimes, right? Okay, so if a polynomial has a rational zero, not all polynomials have rational zeros. If it has one, it will be of the form P over Q.
No, I remember this.
No.
Know your P's and Q's.
Know your P's and Q's.
Oh,
Where
correct.
P is a factor of the constant. And Q is a factor of the leading coefficient. No one's gonna ask me what a constant is?
What's a constant? Number that's constant, right?
It's just the plain old number in a polynomial that doesn't have x on it. Okay, what's the leading coefficient?
The one number in front of
The number in front of the
first.
highest
Yes.
degree. Yep. So if a polynomial has a rational zero, it will be the form P over Q, where P is a factor of the constants and Q is a factor of the leading coefficients. If it has one, okay, that doesn't necessarily mean for sure it will, okay. For example, I'm gonna do example 7, but I'm gonna switch the function up a little bit because I don't like all the stupid ones. They have x cubed minus 5x squared plus 2x plus 8. And I'm going to start by listing all possible rational zeros. And then we're going to actually find which ones actually work. So we're going to start by listing all the possible ones. And then once we have the list of possibilities, we can narrow it down to which ones actually work. Okay, so list all possible. So first I need to find my p's. My p's come from this guy. What are the factors of 8?
1 and
1, 8, 2, 4.
The factors of 8 are 1 and 8, 2 and 4. Right? But they could both be negative. Negative 1, negative 8, negative 2, negative 4. Right? So plus or minus on all of them. Right? Okay, so then what are all my factors of q? So this guy's my q. So 1, right? So what are all my factors of 1?
1 and 1.
1 and 1, plus or minus, right?
Yeah.
Okay. So now I just need to divide them all, right?
This
So it's
was
gonna
one.
have any possible zeros. I need to take all my p's and divide them by all my q's.
1
So I need to take 1 divided by 1. Well, that's 1.
Negative 1 divided by 1.
So can I just write plus or minus
Oh,
1?
yeah.
Okay, so then I would have to take 2 divided by 1, right?
Plus or minus 2.
And then plus or minus 4 divided by 1. And then 8 divided by 1.
Plus or minus 1/2.
Okay, nope, that would be q over p.
Oh, yeah.
Okay, we'd have to go q over q. So when these two numbers were different, I'd have to take each of these over this number, and then each of these over that number.
Both those are the same,
Yeah, I mean, there's no point in listing them twice. So if this has any rational zeros, any at all, it's gonna be one of those 8 numbers. Do you agree there's 8 numbers there? Okay, so it's gonna be one of those 8. So now we need to test them and see which ones work.
Oh, then you have to take.
So how do I find out which ones work?
Plug them in.
Plug it in, right? Is there a quick way of just plugging them in?
Just multiply the whole thing by the. Or put it in for x. Put the negative. I don't know. that'd be
Put
long.
each number in for x?
Yeah.
Okay.
Remainder.
I mean, you could
Okay,
put
I
it
could
down.
remainder theorem it out, right? Or could I do that? Okay. Yes, if I was just trying to find all the rationals, okay? So listing all the possible rational zeros and then now finding the actual rational zeros. Okay. So what's the easiest way to do it using your calculator?
Graphing and graphing.
Graphing and tracing, right?
Oh.
Graph and trace, or I like graph and table. Because one thing about the table is that you don't need to be in the window to get it to work. So I like graphing and tabling. So what did we have? X to the third
Minus 5x squared.
minus 5x squared.
Plus 2x plus 8.
So what do we got? 1. Nope. Negative 1. Ooh, negative 1 worked. There's one of them.
So it has to be 0, the y.
Yep.
Because we're looking for all the zeros, right?
Yeah.
We're not looking for all the 6s. We're looking for all the zeros.
Yeah.
2. Nope, that one works. Negative 2, 4, negative 4, 8, negative 8. So which ones did it have?
1, 2, and 4.
Negative 1, 2, and 4. Negative 1, 2, and 4. So negative 1, 2, and 4 are the actual zeros. How many zeros is this thing gonna have? Do you guys remember?
As much as the highest degree.
As much as the highest degree. So what's the highest degree on this?
I know.
3.
Got pickled juice
Third
on it.
degree. So how many zeros does it have? It had 3. Did we find all of them?
Yes.
So that means all of the zeros for this guy were rational. They won't all be. Okay. So all of the zeros on this guy were rational. Okay. They won't always be. So how do we find them if they're not all rational? Okay. So that's example 9. On page 124. Okay, example 9 is slightly different. It says find all the real zeros of, and then they give me a function. 10x to the third minus 15x squared minus 16x plus 12. It says find all the real zeros. How is that different than the last one?
Possible rational.
It was just the rational ones. They only wanted the nice whole number fractiony ones. This one, they want me to find all of them, whether they're rational or not. Well, first of all, again, we'll refer to Megan. How many should it have?
3.
3. So degree 3, we know it should have 3. So I start, first of all, is it quadratic?
No.
No, it's cubic. Will it factor nice?
I don't know.
Yeah, we could try it.
Yeah, you could do a 2 parentheses group.
Yeah, we could if I group these first two, plus and negative, group these last two. Out of the first two, I could take out a 5x squared, right? 2x minus 3. What could I take out of those ones?
Negative 4.
4. Positive 4x minus, oh, what happened?
It doesn't work.
It doesn't work, because I didn't get the same thing here. Okay, so factoring by grouping didn't work. Scratch that thought. Okay, so I'll try something else. Okay, so another way is to list the possible rational ones and see if it has any rational. It might. So let's P over Q it. So my P's, they're for my 12. 1 and 12, 2 and 6, 3 and 4. Okay, what about my Q's?
Where are you using here?
1 and 10, 2 and 5.
You've got 1 and 10, 2 and 5. Okay, so my P's over Q's,
Oh, there's so many numbers.
Plus
Wait,
Plus or
aren't they all
minus?
plus or minus?
yeah.
Plus or minus 2,
Plus or minus 1 over 1,
5.
plus or minus 1 over 2, 1 over 5, 1 over 10. That was all using 1 as my numerator, right? Okay, so then plus or minus 2 over 1, plus or minus 2 over 2, but don't I already have that in the list?
One.
Okay, plus or minus 2 over 5, 2 over 10, that's 1/5, right? Okay, so I already have those. So plus or minus 3, 3 over 2, I don't have that one yet. 3 over 5, I don't have that one yet. 3 over 10. Now 4,
Oh my goodness.
4 over 2, I've got that one. 4 over 5, I know. 4 over 10 is 2/5, so I've got that one. Okay, and then now 6. 6 over 2 I've got. 6 over 5 I don't. 6 over 10? Isn't that 3 over 5?
Yeah.
Alright, and then plus or minus 12. 12 over 2 is 6. 12 over 5, oh, I don't have that one. And 12 over 10 is 6 over 5. So there they are. Whew. Okay, so now another way is I could start synthetically dividing by these until I finally get a 0.
Did you not do 1 over 3? Or?
I wouldn't do 1 over 3 because you want to go the other way around. It's P's over Q's.
Oh, yeah.
P is purple. Yeah, I know.
Oh, P's per, oh, yeah.
Yes, I switched colors, sorry. I forgot which colors were which. So then now, I don't know which one of these works. I could start an old school before calculators, they would have to just start synthetically dividing by these and keep synthetically dividing until they have a 0. We have an easier way of finding which of these work. Calculator? Okay. Y equals 10x to the third minus 15x squared minus 16x plus 12. Okie dokie. So we could graph. You want to look at the graph? Okay, what look like they are?
Negative 1.
Nope.
Negative 1.3. Can we use the 0 one?
Ooh, 2 works.
Negative
Well, I've
3.
got my list, right? I have my list on my paper that I
Negative
could.
3 halves, try that.
So 2 is on there.
Negative 3 halves.
Nope. All I need is 1. Did I find 1?
Yes.
I found 1. I found 2. That's all I need is 1. Now that I have 1, I synthetically divide by it.
Oh, and then you do it like twice.
Because then I end up with a simplified. So now I would synthetically divide. So we found which one works. 2?
2.
It actually.
X equals 2. So then my factor is x minus 2, right?
Wait. Okay, you're right. Got that. So then you
Okay.
synthetically
So synthetically divide by the 2. 10, negative 15, negative 16, 12. 10, 20, 5, 10, negative 6, negative 12. We get a 0. Which we know we would, right? The calculator said we would get a 0. We know it's a 0. But how did synthetically dividing help me?
Now we have our
Now it's
new.
simplified.
Now we have our new one. We know the one factor is the x minus 2, but what's the other factor? 10.
10x
Oh.
squared plus 5x minus 6.
What's so special about that other one? About this new one?
You can,
It's quadratic. So I could either factor it, complete the square, not complete the square on that, that's messy. So I have to divide everything by 10, right? So then I end up with like a 1/2 and a 3/5 and it's a mess. Okay, so I know I have one solution, x equals 2.
You need
How many
three,
should
though.
it have?
Three. So
Three.
you gotta find that,
So I need to find the solution to this guy now.
and then you gotta, might as well
So could I, x equals negative b plus or minus the square root of b squared minus 4ac all over 2a. So, what, negative 5? 5 squared minus 4 times with my a, 10. My c is negative 6 all over 2 times 10. I'm gonna do the stuff inside my square root in one step. 5 squared minus 4 times 10 times negative 6. I get negative 5 plus or minus the square root of 265 all over 20. Okay, 265. What goes into 265? Is it a perfect square, first of all? Wah, wah, wah. No, it's not. Darn it. 5? But that's not a perfect square. But it could help. Okay, I'm breaking down 265. I divided it by 5, I got 53.
That's all.
I think 53 might be prime.
Yeah, something.
I can't think of anything that goes into 53. 2 doesn't, 3. Oh, 2 and 26. Oh no, that's 53 divided by 2. 53 divided by, I don't think anything goes into 53. So what does that tell me about the square root of 265? I can't simplify it any farther, right? So, what does that tell me about the zeros or solution to this?
Very big fractions.
Yeah, I've got 2. One of them is the 2 that came from up here, right? 2. And what's the other one? Negative 5 plus the square root of 265 over 20, and negative 5 minus the square root of 265 over 20. So there, does it have 3 of them?
Yeah. Yes.
Yes, I found all 3. And guess what? Only one of them would have been found exactly using your calculator. There's no way you could have found those other 2.
Wait, what's the second one? I see 2 plus
The
and
one with the
minus,
plus
like
and then the
two.
minus, that's actually 2.
Oh, it's plus and minus. Oh.
Will
Right?
we be able to find, but we wouldn't find the exact?
You could find the exact. You could find an approximate, if
So
that's
how
all we
can-
care about.
So can we use the 0 one?
You can, but it won't find you the exact. I need the exact.
Yeah. But just to find one maybe? If we can't find one?
Well, you should. You've got your P's over Q's.
Yeah.
If you've exhausted that entire list and haven't found a single one, then something's up. And so I can check these and see if I'm right. I wish I could do picture in picture with this one. Because what were they? So I could trace. I can actually type that in.
Well, you can.
Parenthesis negative 5 plus the square root of 265 divided by, what was it? 20? Guess what I got? Exactly 0.
Oh my god.
Like,
Wait, can you type that in again for x? I wanna see like where your parentheses are.
You have to put parentheses around your entire numerator. So I put parentheses negative 5 minus the square root of 265. So then you see
that,
another
yeah, that
parentheses in your
confused
square
me.
root.
Yeah.
So I'll leave one parenthesis to close the square root
another
and another parenthesis for my numerator. Divided by 20, and look, there's the other one. Your calculator, if you just use a 0 feature, would have gave you the negative 1.0639.
Which
It
is
wouldn't-
approximate, right?
It was approximate, it wouldn't give you the exact. And we need the exact. Okay, and I have a feeling this section is going to be a little bit difficult for us, especially those of us who didn't do the practice, the 2-1 practice completely. And for those people who didn't do the 2-1 practice, all of them, solving, because it involves solving quadratics, some of us did not solve them.
Oh.
Some of us relied 100% on our calculator. You just wrote me an approximately for almost all of them. Like, no, you need to find them exactly. So that's gonna make this stuff a little tough. Okay. Alright, so that's basically, we're completely skipping Descartes' rule of science. He's not even useful anymore. That's on page 126.
That's a little rude.
It was quite a groundbreaking thing back before graphing calculators. Basically, it looked at how did the signs change, like along the polynomial. Like here, this one has two change of signs, because this one's positive, this one's negative. Negative, this one goes negative to positive. So it's got two change of signs, and depending on the change of signs, it would tell you how many of each type of zero it had. But we really don't need that anymore because I can look at a graph of it to tell how many zeros it should have. Okay. Does that make sense? So we don't really need it anymore. It's one of those tricks that's not a trick anymore. It makes things longer. Okay. Alright, so we are working on, so I assigned what, through 24 yesterday?
Yeah.
I want us to do 29 through 60, but we're just gonna do the evens. So, this was 30 through 60. I don't think we've got 10 minutes of class time, and how many problems is that? Like
15.
15 problems?
Is that?
Okay, but some of them get a little long.
We did them all too, so like, if you did it again.
Yes, and I wanna have a chance to go over them first. If we had a full class period tomorrow, I would say yes, but we don't. So, Tuesday. I know.
Oh, I don't think that's
So we're-
No, it's gonna be awesome, because I'm only on 1 to 14. I know, but imagine doing that and then you never remember.
So this isn't due till
Okay.
Tuesday.
So Tuesday.
Okay.
So on Tuesday, we're having a quiz over
Quiz.
2:30.
So Tuesday, on Tuesday, we'll take 10 to 15 minutes, question and answer, on any we have, and then we'll quiz. Okay. If there are any, at any point, you wanna check your answers, my book will always be in here, if you ever wanna check answers.
Can you write the whole assignment
Yeah,
on the bottom?
yeah.
Because I don't even know what the last one was.
49
so-
to 60 even.
1 through 20.
What
Okay,
was yesterday?
127, basically we're doing all of 1 through 24,
Okay.
and then 30 through 60 evens.
Oh, 30.
It's just the 1 through 24, I just broke them over 2 days.
So tomorrow, are we gonna just work?
We'll work in class,
Okay.
answer any questions you have, okay, because we only have 30 minutes.
Is it 30 to 60 even 10 problems?
It's
15.
16.
You just divide it in two.
Oh god, I can't even see right now. I think I'm going blind.
My brain is
Should I drink
broken.
some pickle juice? I ate pickles.
Dude, my stomach hurts now, man.
Oh, I love pickles. I think they do amazing things.
Yeah, it's 16 problems. That's 30 to 60.
It's not bad.
Will you send us that?
Sure. Right.
Are you still videoing?
Yeah, you're
Yeah.
home videos, email it.